Imagine discovering hidden insights in your data that could drive powerful predictions and strategies. Welcome back to Knowledge Academy's YouTube channel. Today, we continue our exciting journey into the world of Exploratory Data Analysis, or EDA, for machine learning. Whether you're a data newbie or a seasoned pro, this tutorial is packed with insights that will transform the way you look at data. Ready to become a data detective? Let's dive in. In our previous videos, we covered data retrieval and data cleaning. If you haven't seen those videos yet, make sure to check them out. In today's video, we'll be focusing on the third component of EDA, data exploration. This step is crucial in understanding the data before applying any machine learning algorithms. First, let's talk about what data exploration is. Data exploration involves examining your dataset's main characteristics to understand the patterns, detect anomalies, test hypotheses, and check assumptions. It helps you get a feel for the data and discover initial insights. There are two main types of data exploration. First is descriptive statistics. This involves summarizing and describing the main features of a data set quantitatively. Second is basic plots and tables. This includes simple visual representations and tables to inspect the data's distribution and relationships. Let's start with descriptive statistics. Let's understand descriptive statistics with an example. We'll use a dataset of house prices for our examples, which we used in our previous videos. This dataset includes columns such as price area, bedrooms, bathrooms, stories, main road, guest room basement, hot water heating, air conditioning, parking, and furnishing status. First in this category is mean median. Mode, very familiar but very important concept. The mean gives us the average value, the median provides the middle value, and the mode shows the most frequent value. These measures help us understand the central tendency of our data. Let's take the data set and try to find mean, median, mode of price column in house price dataset. For calculating this in Python, we will use pandas library and then read the CSV file. Then we will print the mean of price column using mean function as shown. Then same for median, we will use median function on the price column. After that, we will use mode function to calculate mode of price column. Then execute it. You can see all the three things correctly calculated. In this example, we calculated the mean, median, and mode for house prices to get a quick understanding of the central tendency of our data. The mean price is the average house price. The median is the middle value, and the mode is the most frequent price in our dataset. These measures give us different perspectives on the central value of our data, helping us understand the distribution and typical values of house prices. Next is standard deviation and variance. Standard deviation and variance tell us about the spread or dispersion of the data. A high standard deviation indicates that the data points are spread out over a wider range of values. Here, with the same price column of house price data set, we will calculate standard deviation and variance. For this, pandas library will be used, but since we already imported it, we will directly go for the standard deviation and variance code. For this, we will write std for standard deviation along with the column name that is price of the dataset. In the same way for variance, we will use var with price column of the dataset. Here, we calculated the standard deviation of variance of the house prices. The standard deviation measures the average distance of each data point from the mean, while the variance is the square of the standard deviation. These metrics help us understand how spread out the prices are. A high standard deviation means the prices vary greatly from the average, indicating high variability in house prices. Now, let's come to skewness and kurtosis. Skewness measures the asymmetry of the data distribution, while kurtosis tells us about the tailedness of the distribution. We will calculate the skewness and kurtosis of the price column of the house price dataset. For skewness, we will write skew with the column name price of the dataset. Then for kurtosis, we will write kurt with the column name price of the dataset. In this example, we calculated the skewness and kurtosis of the house prices. Skewness indicates if our data is skewed to the left or right. A positive skew means the data is skewed to the right, with a long tail on the right side. Kurtosis measures the tailoredness of the distribution. A high kurtosis value indicates heavy tails or outliers. Understanding skewness and kurtosis helps us identify the shape and characteristics of our data distribution. This is all for descriptive statistics. Now let's see some of the basic plots and tables for data exploration. Although we'll cover detailed data visualization in another video, some basic plots and tables are essential in data exploration. They help us get a visual understanding of the data and uncover insights that might not be obvious from descriptive statistics alone. First, frequency tables. Frequency tables provide a simple way to summarize categorical data. They show the number of occurrences of each category in a dataset, helping us understand the distribution of categorical variables. So, to make frequency table, we will take the main road column from house price data and make a frequency table for it. By writing normal print statement for using value count operation of pandas with the main road column. In this example, we created a frequency table to count the number of houses in each neighborhood. This helps us see which neighborhoods have the most or least houses. By using the value counts function, we quickly get a summary of the frequency of each category in the neighborhood column. This is useful for understanding the distribution of categorical variables. Next, cross-tabulation. Cross-tabulation can show the relationship between two categorical variables. It creates a matrix where the rows represent one categorical variable and the columns represent another, showing the frequency of each combination. Now let's take an example to know how we can make cross-tabulation. Here we will use guest room and air conditioning column from house price table. For this we will write the code as print then pd.crosstab, then the column names between which you want to create the crosstab. Here, we used cross-tabulation to see the relationship between houses with guest rooms and those with air conditioning. This can reveal patterns, like whether houses with guest rooms are more likely to have air conditioning. By using the crosstab function, we create a table that shows the frequency of each combination of guest room and air conditioning. This helps us understand how these two categorical variables interact and can uncover interesting patterns in the data. Finally, basic plots. Simple plots like histograms or box plots can quickly show the distribution of a variable. These visualizations help us understand the spread, central tendency, and any potential outliers in the data. Let's see with an example how we can create a basic plot. For this we will use Matplotlib PyPlot library of pandas. We will be making a histogram for price column of the house price table. For this we import matplotlib.pyplot as PLT. Then to create histogram for price column, you will write the code as column name, then the type of plot. In this case it's histogram. For this we will write hest then in bracket the bins. After that we will give title for the plot, then label for X and Y axis, and then give command to show the graph. In this example, we created a histogram to visualize the distribution of house prices. Histograms help us see how prices are distributed across different ranges. By plotting the price column with 30 bins, here bins 30 specifies that the range of price values should be divided into 30 equal intervals or bins. Each bin will represent a range of values, and the height of the bar corresponding to each bin will indicate the number of data points that fall within that range. We get a visual representation of the frequency of house prices in each range. This helps us identify patterns, such as whether the prices are normally distributed or if there are any outliers. Visualizing data in this way can often reveal insights that might not be obvious from numerical summaries alone. And that's a wrap! In this video, we explored the key aspects of exploratory data analysis. We covered descriptive statistics and some basic plots and tables. Understanding these basics will greatly enhance your ability to analyze data effectively. In our next video, we'll dive into the data visualization section of exploratory data analysis with machine learning. Let's keep up the pace and understand the very basic of machine learning and excel this skill. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.